Okay, so if the friction in the vane is neglected, like this one, okay, so we have your B sub 1 is equal to B sub 1, B sub 2 is equal to your B sub 1, which is also equal to your velocity V. Okay. So what we have here, we have your velocity at point 1, then we have your velocity at point 2. So velocity point 1, so it will be equal to V. Okay, now drawing out yung ano natin, components niya. So this jet was in line with your x-axis. Okay, so we can consider that we have only the x component, so where x component ng velocity ng point 1 is also equal to the velocity of the jet. Okay, compare dito sa velocity at point 2, so we have x and y component ng velocity natin. We have your v sub 2, so this is v sub 2x. Okay, then for your y component going up, so we have your velocity 2 as y component, then we have here your velocity 2, which is equal to velocity v, so that represents. So from our previous equations of our function of force reaction at x-axis, so we have your equation, so f of x, so that will be equal to the density. Okay, then we have your volume flow rate, then multiply by the change in velocity 1 at your x component, then we have your velocity 2 at your x component also. So for this one, change now from here point 1, so we'll put an arrow here to show the direction, no? Okay, so velocity x component ng b ng jet mo, then we will have your velocity at point 2 at the x component niya. So take note, we don't have the y component ng B1 since our jet is acting 90 degrees to the angle, which is usually at 0 degrees, no, from the horizontal axis or in the x-axis. So we don't have your b sub y, b sub 1 y will be equal to 0. So we can rewrite our equation. We have your fx is equal to your density times the volume flow rate. Then we shall multiply this one, since our b sub 1 at x component is equal to b. So we have here your velocity minus, now pagdating naman dito, we have the value of your b sub 2, which is equal to your v. What we don't have, the value is the b sub 2 at the x component. Since we have here the angle, so it's the same angle that we'll be using din dito. So we have your theta dito. So we can solve that one by means of, since this is your adjacent and we have here your hypotenuse, so we can solve that one by means of your trigonometric function. So we will be using cosine. So we have your adjacent and we have your hypotenuse, which is given, and we have your unknown, which is yung velocity 2 at the x component. So we can solve that one by cosine of theta is equal now to your adjacent. We have your velocity 2x, then divided by your hypotenuse, so that will be b2, or let's say that will be b, no? So velocity. So we can solve now the value of your velocity 2. So at the x component velocity 2x now is equal to your, I'm gonna change this one to v. Okay, then multiply this one by cosine of theta. Okay, so we can substitute this one to this equation. So we have now your v, so that will be cosine of theta. Okay, then furthermore we can factor this one. So we have your f of x, so we have your density, volume flow rate, so factoring that one, so we have your velocity, no, that will be multiplied to 1 minus your cosine of theta. So remembering that our volume flow rate, no, our volume flow rate is equal to the area times the velocity of the fluid. So the area of the pipe, or let's say the boundaries, and multiplied by the velocity of the fluid that is used in the inside the boundaries. So we can express our volume flow rate. So we can substitute yung value na ito. So we have now your f of x natin. So that will be equal na to the times the density times that will be your area. Then multiply velocity. Then you have your velocity here, 1 minus your cosine of theta. And we can further simplify this one as density area, then we have your velocity squared, multiply 1 minus your cosine of theta. So we cancel now the values of the reaction along the x-axis. Now let's go to the y-axis. What will be the reaction at f of y, reaction the y-axis. Again, so I'll be writing here, so we have this will be Fy. So again, we have your density, volume flow rate, multiply by the velocity 1, y component, then velocity 2, the y component. So we can write our equation as density, volume flow rate. So take note, kanina sinasabi ko, previously I was saying that our velocity y is 0 since yung jet natin is acting horizontally along the x-axis. So we don't have the y-axis component for the velocity at point 1. So I'm gonna write here 0 minus your velocity 2. So referring to this one, velocity 2 at y component, so referring to this one, so we can solve yung values here, so by means, so that will be the y component, so we can use the sign, so that will be sine of theta, or let us see that is so that will be our opposite. What will be your opposite? That will be velocity 2y divided by the hypotenuse, so we have your v. Okay, so we can now say our y component, that will be v sine of theta. Okay, so substitute that one to this equation, so we have now your v sine of theta. Okay, so since that is 0, so we can say this is f of y, so that will be your density, volume flow rate, then multiply by this is, okay, so we can write this one as velocity v sine of theta. So take note that we disregard yung negative sign, so because we don't have the change in velocity component, so wala tayong change in velocity at the y component. So this is just only for representation, that just in case na there is a y component. Now if there is no y component, so automatically we'll be putting the values, since value of v sine of theta, since we don't have the change in velocity for the y component, so automatically we'll be using the constant velocity that we yung nakuha natin doon. Okay, yung ginamit natin doon sa taas. So From here, we can also express this one. We have your Fy, that will be density. So again, area times your velocity, then multiply by the velocity. Then we have your sine of theta. So substituting that one, we have your density times the area. So this one distributed here, we'll have velocity squared. Then we'll multiply it by sine of theta. Now to get the resultant, so resultant force, so we have here, so that will be the square root, no? Square root of your f of x squared plus your f of y squared. Then let's substitute yung values niyan. So we have now your square root. So that will be yung value ng f of x natin. So I'm gonna square that one. So value ng f of x natin. So that will be your density, area, velocity squared, then multiply by 1 minus your cosine of theta. Then this will be squared plus yung value ng f of y, that will be density, area, velocity squared, then multiply sine theta, okay, then raised to square. So we can rewrite our equation. So we have your f of x is equal now to, we can rewrite it as, we have your density, area, velocity squared. So I'm gonna raise to square this one. Then we have 1 minus close parenthesis cosine of theta, that will be raised to squared. Then plus your density, area, velocity squared. So this will be again raised to square. Then multiply by sine of theta. So this is also squared. Raised to exponent of 2. And we can factor yung equation by means of yung ano yung mga common. We have here the common for sa equation. So we have your density. Okay, so that will be your density, area, plus velocity squared. So I'm gonna raise this one to squared. So we have your common. Then multiplying the equation by 1 minus your cosine of theta. So this is also raised to square plus your sine of theta. So this is also squared. Then pwede natin itong ilabas from the equation of the we can square this one. So we have now your force, resultant force, that will be density, area, velocity squared. Now times the square root of, that will be 1 minus your cosine of theta. So this is squared plus sine of theta. So this is also square. So remembering that we have a trigonometric identities, which is the sine of squared theta plus your cosine of squared theta. So this is equal to 1. So we'll be substituting yan doon sa loob. So first things first, we need to expand yung equation na ito. So expanding that one, so we have your force is equal to your density, area, velocity squared. So we have the square root. So that will be 1. So this is 1 minus your cosine of theta. So that will be multiplied by 1 minus your cosine of theta. Then plus your sine squared of theta. So we have your force is equal now to your density, area, velocity squared. So that will be distributed. We have your 1 dito. So this is 1. Okay. Then multiply doon. We have your cosine of theta. Then another one here, negative. So that will be cosine of theta. So we have here negative to negative, we have your positive cosine squared theta plus sine squared theta. Then we can further reduce yung equation natin into density, area, velocity squared. Okay. Into will be ganito na siya. So we have 1. So sum, we have your common here. You have 2 cosine of theta, no? Plus this one, cosine squared theta plus the sine squared theta. So again, we have the trigonometric identities. Yon. So this will be equal to 1. So we have now your equation reducing into density, area, velocity squared. So we have your square root. So we have here your 1. So this will be your 1. Then this will be 2 cosine theta. So this is now trigonometric, and then this is 2 degree plus 1. Okay, so we can express now our equation as your density, area, velocity squared. So we have your square root. So this is now, so I'm gonna add natin to. So we have 2. So this will become 2. So this is 2 minus 2 cosine of theta. So continuing our solution here. So we can further express this one. So para we can attain the trigonometric identities for call this half angle formulas. So if you can still remember from your trigonometry, so for half angle formulas, we have your half. So for half angle formulas, so we have your sine of theta, no? So that will be equal, this is not, that will be sine of theta, that will be over 2, so that is equal to the square root of, that will be 1 minus your cosine of theta. So we can further reduce yung equation natin by, so yung half angle formulas natin, pwede natin i-expand into, that will be equal to 1 over 2 minus cosine theta over 2, which is equal to, combining that one, so we have common denominator, we have 4. This is 4. So 4 divided by 2, that will be 2. Then this one minus 4 divided, that will be 2 cosine of theta. Okay, square that one. So since nasa loob pa rin siya, square root pa rin siya. Okay, so we can write this one as sine of theta over 2. So square root of 4. So bali mangyayari dyan. So we have the square root dun sa taas. Okay, that will be square root of 2 minus 2 cosine of theta. Then this is the square root of 4. Okay, so we can write now this as 1 over 2. So square root of 4 is 2. Then multiply by 2 minus 2 cosine of theta. Okay, so ang kailangan lang naman natin is this one, 2 minus 2 your cosine theta. So pwede natin ilipat ito doon sa kabila, this side. So we can write now as 2 sine of theta over 2. So that is equal to the square root of 2 minus 2 cosine of theta. So from here, we can replace now yung part ng equation na ito by nito. Okay, so we can write now our force, okay, is equal na to your density. Okay. That will be area, no, times your velocity. Okay. Oh, sorry, this is the velocity squared. Then the value, that will be 2 times sine of theta over 2. Okay, or we can finally write this as 2 times your density, area, velocity squared, then multiply by sine of theta over 2. Now, that will be the value of our resultant force for the fixed curve plate reaction from your fixed curve plate. So looking again the overview of our solution for the derivation of your reaction or the total resultant of force acting at our given acting of the of this fixed plate on the reaction from the flow of jet horizontally on the surface, then going up here at an angle of theta. So we have here the value of what will be the value of the total resultant. So you just only have, if the given angle sa problem, so if the given value, you have your theta and the given velocity, so we can now solve the values of your resultant force. So kung ito given na yung ano natin, yung theta and angle, so repairing that one to the schematic diagram. So kung given na yung theta and we have the velocity, okay, so we can directly compute what will be the force of the resultant. Since your area, that will be the area of the, so yung area, usually that is yung area ng ano nito ng jet. So what will be the area of this part, the nozzle. Okay, so substituting that one, if you have your velocity now, so this is density is will be given. So sometimes it will be water, mostly water ang gamit, no? So that is nozzle. Then we can solve the resultant force that is acting on reaction ng plate na ito. So what will be the reaction of the total resultant of this plate? And furthermore, we can also to solve yung angle, no, ng reaction of force na ito. So we have again the tangent of theta. So that will be equal to the force y-axis, okay, then divided by the force on your x-axis. So we can determine, so what will be the angle, no? So what will be the angle of your resultant, kung saan siya naka-angle from the x-axis.